Hello, we're team number 1 and we're going to talk about the conic section of a circle with life applications with the eco environment. In this group we have Bryan Holguín, Oriana Briceño, Alejandra Vitiello, Enmanuel Camacho, and me who is speaking, Ámbar Duran. For no further ado, let's get on the video.
Hello, I will be introducing the concept and definition of conics and circles. For starters, a conic section, or simply a conic, is a curve obtained in an intersection of the surface of the cone with the plane. The three types of conic sections are hyperbola, parabola, and ellipse. The circle is a type of ellipse and can also be considered to be a fourth type of conic section. A circle is formed when the plane is parallel to the base of its cone. Its intersection with the cone is therefore a set of points equidistant from the central axis of the cone, which meets the definition of a circle. All circles have a center point and a radius, which is the distance from any point of the circle to the center point. Circles are all similar and can be transformed into one another. On a coordinate plane, the general form of the equation of the circle is x minus h squared plus y minus k squared equals r squared, where h and k are the coordinates of the center of the circle and r is the radius.
So now we're gonna continue with the exercises part, in which we have two exercises, one with the standard form and one with a non-standard form in which we have to convert it into a standard form. So let's go to the first exercise. So in the first exercise we have x minus 3 squared plus y minus 4 squared equals to 81. This is really easy. So we take this x minus 3, pass it right here. So x minus 3 is equals to 0. So we pass the minus 3 to the other side, making it x equals to 3. We have the x component now. And we now go the same way with the y. So y minus 4 equals to 0. So we pass the minus 4 to the other side, making it y equals to 4. So the center of the circle is 3, 4, x component and y component. And now, the same with the radius. Now we have the center, but we have to get the radius of the center to make the circle. So, the radius squared is 81. So we pass this squared as a square root to the other side, making it square root of 81, which is equals to 9. So the radius of this center is 9. And we now go to the graph. As in the graph, we count first the center and then the radius. So 1, 2, 3, 1, 2, 3, 4. This is the center right here, 3, 4. And we now count 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we now have 4 dots around this center, and we connect each dot until we get this perfect circle around this center.
Hi, I'm Alejandra and I will be explaining today how to turn standard equations into conic sections. First of all, the standard equation is x minus h squared plus y minus k squared is equal to r squared, where r is radius and h and k are the coordinates to the center of the circle. To figure out the value of each, we must first square everything, so we may end up with something like this. Next, we will pass all numbers without a variable to the other side of the spectrum and place numbers with similar variables together. Now we take whichever term is squared up and divide that number from each and every single one of the numbers. This next step is a bit more complicated. We take the coefficient of the x term, multiply it in half, square it, and then add that number to both sides of the equation. Now, we'll repeat the same step with the y term. Convert the left side into a square shape and simplify the right. Finally, all that's left to do is read the answer to the rearranged equation and graph our coordinates onto the y-x plane. Simple, right? Now I'll pass you over to Bryan, who will present you with a real-life example for further comprehension.
So we now proceed to the second exercise. As I told you, we have to convert an equation from a non-standard form into a standard form to proceed with the past exercise already done. So we now go to the exercise. Okay. So we have this. Okay, right now. So we have this equation, which is 2x squared plus 2y squared minus 12x plus 8y minus 24 equals to 0. So we pass the same equation right here, and we have to get this x and y squared without this number multiplying them. So we have to divide. So we divide by 2 everything that is on this side of the equation, not on this side. So divided 2x squared divided by 2, 2y squared divided by 2, minus 12x divided by 2, plus 8y, divided by 2, and minus 24 divided by 2. Getting us to x squared plus y squared minus 6x plus 4y minus 12 equals to 0. We can now proceed. And we have to organize this part. So this x and x, we make a group, we divide it by groups. So we make a group of x and a group of y's. And when we pass this number without a letter to the other side. So we have x squared minus 6x plus y squared plus 4y equals to 12, because we pass this minus 12 to the other side, making it 12. And we now have to get the perfect trinomial. So we have to take this number right here, which is not squared, divided by 2 always, and squared. So minus 6 divided by 2 squared minus 6 divided by 2 is minus 3 squared is 9. And the same in here with the y group. So 4 divided by 2 is 2, squared is 4. And we have now the perfect trinomial. So it's x squared minus 6x, the same as here, plus 9, the number we obtained from the perfect trinomial, plus y squared plus 4y, the same, plus 4, the number obtained from the perfect trinomial. So now, this equals to 12, the number we had already, plus 9 and 4, which are the numbers of the perfect trinomial. We have to put them on this side of the equation and on the other side of the equation. And all this is equals to 25. So we now, to get the standard form, we need to convert or get the square root of these numbers. The first and last number of each group, the x group and the y group, taking the signs in between. So square root of x squared right here minus this first sign, square root of 9, plus the sign right here, square root of y squared, plus first sign, the sign between y squared and 4y, plus square root of 4, making it x minus 3, as square root of 9 is 3, and we have this negative sign, squared, plus the sign in the middle, y minus 2 as square root of 4 is 2 and taking this positive sign squared. So this is equals to 25, the number I told you already. And we now can do the same as we did in the past exercise. So x minus 3, taking it to here, equals to 0. So x is equals to 3. Y plus 2 equals to 0. So y should be equal to minus 2. Getting the center with the x and y component, which is 3 comma minus 2. And for the radius, we have 25. So the radius squared is 25. We pass this squared as a square root to the other side. So square root of 25 is 5, making the radius 5. And we now go to the graph. So we're at the graph, and we first, as I told you last time, we have to get the center and then the radius so we can make the circle. So 1, 2, 3, minus 1, minus 2. So this is the center right here. 3 comma minus 2. And we, from this point, count in each direction 5. So 1, 2, 3, 4, 5. We have one right here. 1, 2, 3, 4, 5. Another right here. 1, 2, 3, 4, 5. Third one. 1, 2, 3, 4, 5. And we have the 4 dots, which we have to connect in a circular way to make a perfect circle around the center.
Live applications of a conic section circle. Number 1, we have car tires. Car tires are a good example of circle or conic section because they have to be exactly round or the car will not run correctly. The tires and the wheels being circles is useful and most important because without that, car tires will be very bumpy and uncomfortable. Watch faces. Although not all watch faces are perfectly round, the majority of the watches may do have a circle of face. It's useful to the watch face is a circle because it can help us to tell the time currently. When we are dealing with a big and a little hand, we can also see it in Ferris wheels because they're circular. Mostly pizzas are circular. Conic sections are everywhere, shown by the water rips from the raindrops.
Architecture. The advantages of the use of circles in architecture is a better behavior regarding winds and solar radiation. In a facade of perpendicular walls, the orientations are direct. However, in the facades of a curved, orientations are diluted, improving the use of the solar radiation and diminishing the penalized surfaces of their orientation concerning the loss of gain of heat. Advertising. It is observed that the circle is the most liked shape in the advertisement and media industry. Most of the logos are circular or oval shapes. This is because the circle resists destruction of vision and acts as a focal field towards which the viewer's attention is continuously attracted. Ecological. Concentrated solar power systems, also called CSP system, generate solar power by using mirrors or lenses to concentrate a large area of sunlight onto a receiver. Electricity is generated when the concentrated light is converted to heat. Among the largest CSP projects are the Ivampa solar power facility in the United States, which uses solar power technology without thermal energy storage, and the Warsaw solar power station in Morocco.
To conclude our presentation, we've properly introduced, defined, explained, and given various examples of conic circles. Circles being the outcome of a parallel plane intersecting with a cone. They're easily adaptable and not hard to comprehend when dealing with their formula.
It is something we encounter constantly in our daily lives, as we have already explained, in various things such as the sun, car tires, watch faces, architectural design, and even advertising. Conic sections and the importance they have in society are things we tend to overlook, but by looking at it and learning about it, we can gain further insight on how our world exactly works. Thank you so much for your attention and hope you enjoyed.